Hello, good evening, good morning, good afternoon, whatever time of the day you are watching this. Welcome to my channel. My name is Emmanuel John. I've been on the journey of giving a high quality training to JAMB candidates who are very serious and have a goal of having a high score in JAMB this year. Yeah, I am a living testimony. I have had about 332, and I believe that every student who worked hard and have appropriate strategies at their disposal would be able also to come out with flying colors. So if this is your first time of coming across my channel, you are welcome, and I'm glad to have you. If you feel you are one of such students that is ambitious and is willing to make a commitment towards preparations for JAMB this year, I won't mind if you join my coaching class. It is 100% free, but this is how it works. I have two WhatsApp groups where I give tutorials, and these WhatsApp groups are the common and the special. The common is for everybody. If I observe you are committed, you are serious, I will now move you to special group where I give extra or more attention to those students because they have demonstrated a high level of commitment. So I also feel they worth more my time and attention. So if you are willing or you are interested, drop it in a comment box and I will attend to you. Today we are going to look at an important topic. Don't forget why I'm doing it this way, because before I only treat past questions, but I later observed that past questions is not enough. Whereas I was adopting a particular strategy in that any past question I treat, I try to explain things around that question in case JAMB decide to ask things around that question. But I realized that it's still not enough. So the current strategy I've adopted is sorry about that, please. Yep, thank you. All right, so the current strategy I've adopted is to treat the syllabus, after which I will now treat the past questions that are related to that particular topic. This helps because I would be able to explain several concepts that might not have appeared in the past questions in case JAMB decide to have time to ask small things that are by the side around a particular topic. So this is why I adopted this method. I have observed other channels, and I appreciate my colleagues who have also been working, posting videos on YouTube to see how they assist you to make it in JAMB. But then I feel they should go an extra mile to adopt things like this. Yes, because it will be more helpful rather than just treating past question. Number one, the correct answer is A. Number two, the correct answer is C. I don't think is enough. It's not very enough. So join me into this journey as we look at the first topic in chemistry in JAMB syllabus 2025. Let's look at it very quickly before we run into the past questions. All right. Yeah, so first of all, we have the separation of mixtures and purification of chemical substances. You need to know what pure and impure substance is and how to ascertain a purity of a substance as a student of chemistry. This is very important. So, pure substances consist of a single type of element or a compound with a fixed composition. For example, distilled water is a pure substance. It has a sharp boiling point and melting point. These two are actually the factors that are basically used to ascertain the purity of a substance. A pure substance has a fixed boiling point. A pure substance that is solid has a fixed melting point. So an impurity affects these two. It will either drag it to the negative or the positive side. But in most times, it increases or it decreases depending on the kind of substance you are using. An example is this. If I add salt to water, the salt is now an impurity. If I want to heat that water, instead of the water to boil, the salt water now to boil at, which we call a solution, instead of it to boil at 100 degrees Celsius, it won't boil because of the salt I have added. So the boiling point changes. Adding impurities increases the boiling point. What if I now decide to add sand into iron? Maybe before iron becomes solid, when it is still in its liquid state, I now quickly add sand and the iron becomes solid. If I want to melt it again, what happens to its melting point? The melting point reduces. Do you see the two are opposite? You need to get this very clear because I bet you cannot escape question from this angle. You just can't under purity. I have studied JAMB questions again and again over the past years. Questions appear in different forms, so please note that. Alright, so that's the difference between a pure and impure substance. A pure substance consists of a single type of element or a compound with a fixed composition. But an impure substance contains two or more substances physically combined together. For example, seawater. Seawater has salt, so it's a mixture of salt and water. Air is a mixture. We have nitrogen, oxygen, argon, and so on. Crude oil is a mixture of diesel, petrol, methane, and so on and so forth. So please note this. Alright, so I've already talked about this boiling and melting point. Yep, let me put it in this way. I've already talked about boiling and melting point as a criteria to determine purity, and I believe that it is clear. So let's go to the next. Alright, so element, compound, and mixture. What is an element? You should be able to know what an element is. You should be able to know what a compound is, and you should be able to know what a mixture is. So when we talk about an element, we are talking about a pure substance made up of just one type of atom. When we say this is sodium, sodium is an element. It's made up of only sodium atoms. That's an element. When we talk about aluminium, we mean that that substance is made up of aluminium atoms only. There is no other atom found in it. That's what we refer to as an element. When we come to a compound is a substance that is formed when two or more elements, chemically, not physically, this time around. Now, this is what makes a compound and a mixture differ. Whereas a compound is when two or more elements chemically join together or combine together. A mixture, two or more are physically joined together and can be separated by physical means. I hope this is clear. So this is what makes a mixture and a compound different. Example, water. Water is represented with a chemical formula H2O, which means two atoms of hydrogen plus one atom of oxygen. And these together are two different elements chemically combining together to give us water. Carbon dioxide, 1 atom of carbon, 2 atoms of oxygen chemically combine together to give us carbon dioxide. That's a compound. So when we talk about a mixture, we said 2 or more substances physically combine together. For example, sand and salt. They are 2 different substances. When combined together, we have a mixture. I hope this is clear. Let's quickly move. Alright, so we talk about physical and chemical changes. See, take this place serious. You won't also escape question here. Because one of the objectives that I saw under the syllabus is that you should be able to, you understand, know the difference between physical changes and chemical changes with examples and their real life applications. Do you see this? So once you are able to master these small topics, believe me, you have already answered some questions in your JAMB because you can't avoid questions there. So what if you have now come to master them? That's a very good advantage. Alright, so let's quickly look into that. So chemical, okay, and physical changes. Substances changes from one state to another. Liquid to solid, solid to gas. We call it state of matter. Do you get it? Alright, so some of these changes are permanent. Some of these changes, they occur chemically, some occur physically. So a chemical change results in the formation of new substance with different properties. The properties of the end product are completely different from the properties of the starting products. I hope this is clear. For example, if you burn wood, the end product is ash. Is ash the same with wood? Never. Rusting of iron. When iron rusts, it becomes reddish brown. The properties of the rusted iron and the previous one, are they the same? So this is a chemical change. Milk turning into sour, that's fermentation. That's a chemical change. Do you get what we're talking about now? Yes. Alright, so let's look at physical change. Physical change does not alter the composition of the substance and is often reversible. For example, ice melt into water. You can still turn the ice, the water that has melted, or the water that is from the ice back to ice. Do you see that? So the properties of water and ice, ice to water, don't change. So that's a physical change. The melting of candle wax, candle, adding sugar in water, adding salt in water, you can still recover your salt and recover your water. So this is what we mean by physical changes. Let's move on. Alright, so I have separation techniques here, which are also important part of chemistry, and you should be able to, at each point in time, know all this because they are very important. Alright, let's quickly run through them. Evaporation. Evaporation is a separation technique that involves separating a solid from liquid, dissolved solid from liquid. For example, if you put water in salt and the salt solution, you can actually evaporate it. You can set it on fire and all the water evaporates. Then you recover your salt. This is what we call evaporation. Then we have simple distillation. Simple distillation separates liquid from solution based on boiling point. Difference in boiling point. More like miscible liquids, like let's say ethanol and water. The boiling point of ethanol is about 78 degrees Celsius, if I remember clearly, and that of water is 100 degrees Celsius. So if you want to separate them, when they mix together, they dissolve in each other, they disappear in each other. That's miscible. They are miscible. Unlike oil and water, which are not miscible, that is, they cannot mix together. So If you have this kind of mixture, you can separate it using simple distillation. Is that clear? But that of water and oil, let's say groundnut oil, palm oil, when you pour palm oil in water, what happens? The palm oil remains at the top while the water at the bottom. So you can use separation funnel to separate that kind of mixture, but not simple distillation. So distillation has to do with miscible liquids that mixed up together. I hope this is clear. All right. We have fractional distillation when you have a mixture of many substances with different boiling points. You adopt fractional distillation. Example is fractional distillation of petroleum, where you remove methane, you remove diesel, you remove petrol, you remove kerosene, you remove different kind of products from it. So the boiling point sometimes is usually very close. The difference between the boiling point of one distillate with another is too close. Unlike in simple distillation, where the boiling point may differ, may be a bit far from one substance and another. I was given an example of ethanol and water with 78 degrees and 100 degrees Celsius. Do you see that there is a difference? But in fractional distillation, the difference may just be a few degrees Celsius. So that's fractional distillation. Sublimation has to do with separating solids that sublimes from a mixture. For example, you can separate iodine from sand. Iodine sublimes, that is, it changes from solid to gas without passing through the liquid state. I have seen this question again and again. I hope you take note of that. They say a substance that changes from solid to gas, a process by which a substance changes from solid to gas without passing through the liquid state, is called what? Sublimation. Thank you. So a good example of separation you can do with that is iodine from sand. Iodine sublimes. If your iodine falls in sand and you still need both of them, or you need iodine, you can subject the mixture of sand and iodine under heat. So the iodine sublimes, it changes to gas completely. So you can now trap the gas and find a way of changing it back to solid. I hope this is clear. Then we have filtration. This is very simple. I don't need to waste time here. Then we have crystallization. This separates dissolved solids by cooling a hot solution. Example is sugar from sugar solution. Yes. So when a solid substance dissolves in liquid and it is a kind of substance you can remove or you can separate by crystallization, you have to heat it until the solution becomes saturated. When it becomes saturated and you allow it to cool, it will form granules. It will crystallize, form crystals. Then you can now filter it to remove the liquid from the mixture. Then we have chromatography. This separates components of a mixture based on solubility, separation of colors. Like ink color can be separated into different color components, and this can be achieved due to the use of the process of chromatography. Different colors move at different speeds on paper, which we call stationary material, depending on what you are using. It can be paper. If you are using column chromatography, we have different types of chromatography. Yes, so but paper or thin layer chromatography is the common or popular one. So you separate colors. This is the basic example that they give you at your level. But when you advance, you find out that you can separate different other components, especially in drug discovery. You will find out that you can separate different kinds of components using chromatography. Then we have also magnetism or magnetization, where you can pick up substances that gets attracted to the magnet from sand or any other mixture that cannot be magnetized. So this is simple. Example is iron filings. You can remove iron filings from sand by using magnets. Yes. Then we have decantation, a process where you allowed an insoluble solid to settle down. Then you now pour it gently, transferring the solid one gently. As soon as the liquid one finish, you just, so this is a popular method. This is a popular method of separation. All right, so let's quickly look at applications in everyday life. Filtration in purification of water, evaporation in salt production from sea water, which is done at industrial scale. Then we have distillation in alcohol purification. We have chromatography in drug testing. Okay, I think I've already talked about this. Let's quickly look at the past questions that are related to this. All right, the first question says, a mixture of sand and salt can be separated by, listen carefully, sand and salt can be separated by what? Okay, so if sand mixes with salt, first of all, you have to put water to dissolve the salt. And then after you put water to dissolve the salt, you decant to remove the salt solution. Then you throw away the sand if you are not interested in it. The salt solution is now subjected to evaporation. So it involves filtration and what? And evaporation. I hope this is clear. Question 2 says, a pure substance has a dash. A pure substance has a, the correct option is B, fixed boiling and melting point. I've already said this during my explanation. Question 3 says, which of the following changes? Okay, which of the following is a physical change? Physical change. Rusting of iron, is it a physical change? Never. Burning of paper, is it a physical change? No. Melting of ice, is it a physical change? Yes. When ice melts, I've stated it earlier, you can still change the water back to ice. So this makes it become a physical change. All right, so let's look at the next question, which is question 4. A mixture of iron filings and sulfur can be separated by magnetization. Yes, I hope you've heard me. All right, so the correct answer is magnetization. Sulfur cannot be attracted by magnets, but iron filings can be attracted by magnet. So you can use the magnet to easily separate them. The fifth one says, which separation technique? All right, sorry for that interruption. All right, so let's continue. So I've answered question 4. Now question 5 says, which separation technique is used in refining crude oil? Filtration? No. Fractional distillation. So B is the correct option. Question 6 says, paper chromatography is used to do what? Yes, remove colors in ink, which is correct. I've said this. Alright, question 7 says, the process of removing water from salt solution is called what? Evaporation, which is the second. Question 8 says, which of the following is an impure substance? The correct answer is air. We say air is a mixture. Do you remember? Nitrogen, oxygen, and carbon dioxide, even argon. There are several components, even dust particles. So air is a mixture. Question 9 says, in simple distillation, the component with the lower boiling point, does what? Evaporates first. That's just it. So the component with the lower boiling point evaporates first before the component with the higher boiling point. Last question says, which of the following mixtures can be separated by sublimation? Of course, iodine and sand. Thank you very much for staying tuned. If you did not subscribe to this channel, I don't know what you are waiting for. I don't know if you are getting any value that you just want to go like that. You cannot subscribe. Okay, subscribe, like, and drop your comments so that others also will see this and have access to this. Ensure also you share with your colleagues who are preparing for the same exams. Thank you.